We are on the combined gas law part of these notes. And actually, let me find the notes so I can see what you're looking at here. We're on the combined gas law part, which basically just combines the gas laws. That makes sense, right? Whoa, that's not at all where I touched. Again, it's not. Okay, so I'll touch the book, and then there we go. Or I could just align it, but I don't feel like doing that right now. Okay, so we did Charles' law. We're done with that. Combined gas law. Oops, let me back up. Yep. I know, very unprofessional, right? Okay, so here's the good news. You don't have to remember all three gas laws. The bad news is you have to remember one gas law. And that's the one. All right? So do you already have this one on your paper? Yeah. All right, so be sure you know this equation. P1V1 over T1 equals P2V2 over T2. That just basically takes the gas laws we've learned and just mixes them all together. Okay? Yeah, that you need to know. All right? Now, here's the thing. If you know this one, you know all the others. Okay? Because if I have a problem that just has pressure and volume in it, just cover up the temperature, and now you've got your P1V1 equals P2V2, right? If you have a problem that just has volume and temperature, then cover up the pressure, and you got V1 over T1 equals V2 over T2. Now, the other useful thing about this, we haven't really talked about this relationship yet, but let's say you have a problem where you just have pressure and temperature. Okay? Cover up the volumes. T1 over T1 equals P2 over T2. All right? So you can solve any of those relationships you want to. Now, let's say you have a problem where you've got all three of these. Then no problem, just use this formula. Yes, sir?
Do you watch a video?
I do not. I do not watch my own videos. Yeah. Okay, well, I'm glad that you're enjoying the videos, but no, I do not. Yeah, that's going to happen right now, right? And we just created one of those moments on the video. Good job. Okay, so point is, this is the only gas law that you need to know. And by that, I'm lying to you a little bit because I'm going to teach you another one later that you also will need to know. But up till now, this is the only one that you need to know. All right? P1V1 over T1 equals P2V2 over T2. All right? You probably have already accidentally memorized it. Just by my saying it 3 times. It's in there, right? You got it. Yeah. Okay. So that's the combined gas law. It's using Boyle's law, combining it with Charles' law. That's kind of nifty. Ernst does a good job with these. And then also combined with Gay-Lussac's law, which we did not talk about specifically, but that's another law that combines pressure and temperature, okay, and talks about the relationship between those two things. But there it is, okay? You don't really, again, you don't need to know the names. I don't care if you know Boyle. I don't care if you know Charles. I don't care if you know Gay-Lussac, all right? You just need to know, all the formula, okay? Because if you know how to use the formula, it doesn't matter if you know the names. All right? So the combined gas law problem, an example of a type of problem you might have here. Sample of helium gas has a volume of 0.180 liters, pressure of 0.8, and a temperature of 29 degrees Celsius. What is the new temperature in degrees Celsius of the gas at a volume of 90 milliliters and a pressure of 3.20 atmospheres? Okay, so now we're basically just getting, we're adding a little bit of length to these problems, but I wouldn't say we're necessarily adding any difficulty. Yeah, I know. That does happen a lot. So you get something in here, and it's like, oh, well, I'm now going to add one more thing that you might not get.
To watch it this time. Thank you.
What the Lord? All right. So, wow, that's way off. Okay, I'm going to have to align this thing. I'm sorry. I can't handle that when I'm writing. Give me a second. So, you know, we're recording this, so I'm just going to talk about the fact that we're recording it while I'm doing this so that there's not just this silence on the video that you guys will watch later and think, okay, we're back. So P1V1 over T1 equals P2V2 over T2. That's the combined gas law, all right? So, again, what I strongly recommend on these problems, and I think I did this on the homework, it may have gotten a little bit messy as you were looking at the answer key, but I tried to label all of my variables as I was looking at the problems, okay? And I think that's a really good idea because it just helps you to keep things straight, especially now that we've got... Right. Yeah, so you'd put it on every single variable in the problem. Because when you get to a problem like this, now there's a lot of numbers floating around, right? So it can get a little confusing if you don't do it that way. So a sample of helium gas has a volume of 0.180 liters. Okay, so that's volume, right? So let's call this our V1. It could be our V2, doesn't matter, okay? But that same sample has a pressure of 0.8, okay? So this volume and this pressure are connected. So if I call the volume V1, then this pressure right here needs to be P1, this 0.800. And a temperature of 29 degrees Celsius, okay? Right. So if I called this V2, the 0.180, if I called that V2, then the 0.8 would have to be P2, all right? Now this temperature, again, this temperature is connected to the ones that I already labeled V1 and P1, so this needs to be my T1, okay? What is the new temperature of the gas? So the new temperature, we're actually trying to find T2, okay, at a volume of 90 milliliters. So that's, throwing out all the stops on this problem. That's our V2, right, and a pressure of 3.20 atmospheres. So that's our P2. Now there's a couple things that I notice here. And maybe are you going to point one of those out to us? We do have to change it to Kelvin, so that's one of the things that I was going to say, all right? That temperature, remember, I said with any of the gas laws, your temperature has to be in Kelvin, period. There are no exceptions, all right? So that 29 degrees Celsius needs to be changed to Kelvin. So how do we do that? Add 273, all right? So now I'm going to start plugging stuff in here. Our V1 is 0.180 liters. 8.00. Or the 0.800, you mean? No, that does not matter if you do that first. You can actually, you probably should do that first. Sorry. I mean, it doesn't matter, but just so that we're writing it the same way we wrote the equation. 0.800 atmospheres times a volume of 0.180 liters divided by our temperature, which is 29 plus 273. Okay? So it's 302 Kelvin. Everybody okay with what I just did right here? So the 29 degrees Celsius, I basically added 273 to that to change it to Kelvin. That gave me 302, all right? You cannot put a Celsius temperature into a gas law problem. You just can't. It's got to be Kelvin, okay? All right. Now that's equal to P2. What's our P2? Pressure, so 3.20 atmospheres, right? Now here's where it's tricky, and you might just miss this if you're not paying really close attention. What's our V2? 90.0 what? That's not right. Because this is liters, right? These volume units have to match. So we have to change milliliters into liters, or we have to change liters to milliliters. I don't care which way you do it, okay? Honestly, if I had been thinking ahead a little bit more, it's probably easier to change the liters to milliliters, right? Because then you multiply by 1,000. But let's just do dimensional analysis here really quickly. 90.0 milliliters. Okay, milliliters on the bottom, liters on the top. There are 1,000 milliliters in a liter. Did you guys know that? You should probably know that at this point. Did you guys learn the stair-step thing in middle school? That's a good way to remember. Well, okay, you don't remember it. Maybe we can talk about that again, because I want you to know, the two that I really do want you to know I want you to know how many milliliters are in a liter, milligrams in a gram. I want you to know the prefix milli. And then I want you to know the prefix centi, right? There's 100 of those in one of the base unit. And then I want you to know kilo or kilo. Kilo sounds better, okay? So like a kilogram, there's 1,000 grams in a kilogram. Those are the major ones that you see come up often, okay? Because this gas law test is not really about whether you know those, I may give you that conversion on the test, but eventually I do want you to know those, okay? So I'm taking 90 divided by 1,000, okay? So that's going to give me a small number, which is kind of unfortunate. Like I said, it might have been nicer to go the other way, change the first volume into milliliters, but this is going to give me whoops, I don't know what that means, 0.0 something. 0.090, did I do that right? Yeah, liters. Except I didn't do the sig figs right, did I? Shame on me. There we go. Need to be 2 zeros after the 9 so that we keep our 3 sig figs. All right? So you have to pay attention to that. When you're doing these combined gas law problems, the units need to be the same from one side to the other. Okay?
So you said you're going to give us like on the tomorrow you can do this?
Yeah, I'll give you conversions. So 0.0900 liters. Okay, now our units are the same for both volumes, so that's good. And then we're trying to solve for T2, right? This one's tricky. So you've got 2 choices on these. You can cross multiply, right? And then solve for T2. So basically, if you cross multiplied, you take the 0.8 times 0.1, and then take that times T2, okay? That would all be on one side. And then your 302 times 3.2 times 0.09, that would all be on the other side of the equation. All right? So you'd have, I don't know what you would have. When you take 0.8 times 0.1, 0.18, sorry. You'd have, 26. Oh, that's right. Okay, well, tell you what, we'll have to finish this when you come into class tomorrow, okay? We'll review, and then we'll take the quiz, okay? No, not until tomorrow.